And welcome everybody to our Solstice stream. We'll be packing our space weather and meteorology segments all into one video today. So join us for the first moments of summer. And thanks everybody for tuning in. This one's a YouTube exclusive. And we'll be back in just a moment here to get things rolling. Alright, so I'm your host Dan, aka Smash-O-Mash, and let's do this thing. We are looking at the sun here in colorized magnetogram and 171 angstroms. There is a new sunspot having just risen over here on the eastern limb. It's pretty significant in size. So far it's only an alpha class sunspot. We only see one polarity to the umbra. So here's your colorized magnetogram. Also, I would note this sunspot up here is continuing to spread apart from itself. You can see that leading umbra accelerating away from the trailing umbra and also growing in size a little bit. So likelihood of solar flares is indeed quite high. Allow me to vanish and cite the radio flux. The 10.7 centimeter radio flux now at 137 solar flux units. And there it is in context. The black line is the one-year chart of the 10.7 centimeter radio flux, also known as the F107. It's the most proportional data set that we have to sunspot number. So there you have that. By the way, YouTube viewers, we typically stream this content onto Twitch, twitch.tv/Smash-O-Mash. So here we are in the Space Weather Enthusiasts dashboard, and NOAA forecasting a little geomagnetic unrest late in the day on June 23rd. But that's about it. We are seeing the likely arrival of a coronal hole high-speed stream, the density wave at the leading edge of it. We'll get to it a little bit later in the video. Now, let's talk about the solstice. It's coming. It's about to be the darkest day in the southern hemisphere, but the brightest day in the northern hemisphere. So at the moment, we are only 4 minutes and 22 seconds away from the solstice. So we find these things interesting, and we typically do live streams on the solstices and equinoxes here at the Smash News Network, least busted name in news. Once again, thanks for tuning in, YouTube viewers, and feel free to leave us comments. We will put them on the screen. There you go. There are your comments. Thanks for leaving comments. Smash-O staff and all the sun. And let's get back to where we were here. Next thing we're going to look at is global seismicity. So let's take a look at what's been shaken as far as earthquaking. There's the past 90 days, and it's been a light 90 days in terms of large earthquakes. You can see only 2 of them showing up there on the bar graph. Let's see what's been happening over the past 24 hours. So it looks like, once again, nothing in the 6 magnitude range. There's some low magnitude 5 range earthquakes there around the South Sandwich Islands. And here's a 5.4. That's around the largest of the past 24. That 5.4 happening at Vanuatu at 1909 Universal Time last night. Now, what else do we have that's noteworthy? It looks like a quake around El Paso, Texas. Leave us a comment if you felt that earthquake. It's of a pretty small magnitude. Largest quake of the past 24 was a 5.9. South of Japan there, near the Bonin Islands. And let's take a look at volcanoes as well. So we haven't been typically putting up this content on YouTube lately, but today it's a special day, so let's change things up. Shivaluch is erupting, volcanic ash not identifiable in satellite imagery. Please don't attempt to pole vault the caldera. And let's go check our countdown timer here. How close are we? Only 2 minutes from the solstice. Semeru also erupting, flight level 140 from Semeru, located on the Isle of East Java. Flight level 220 over the Colombian Nevado del Ruiz volcano, which is exploding. Sangay exploding as well. 21,000-foot ash plume from Sangay. And that same nation, Revenador, also exploding. Flight level 150, a 15,000-foot ash plume. And Sabancaya closes out our volcano list there with a 22,000-foot plume of volcanic ash. Please don't pole vault the caldera. Universum liberate. We want you to be free. We don't want to breathe you in. So don't become part of the lithosphere. Don't become part of a lava lake and pole vault the caldera. It could be unhealthful. Please do visit the links below our video and on our homepage at smashhomash.com. We've changed the coloring of the Smash News Network Least Busted Name and News logo to make it a more summery series of colors. We've gotten rid of our spring colors, all those pastels, and we are on the summer colors. So let's bring up our countdown timer here. It's countdown to extinction of your souls. They'll be demolished and cast into the river Styx, or into an ever-deepening and darkening abyss of raining dog poops and other all kind of dog poops and possibly COVID test kits. Yes. So it's the final 30 seconds of spring here in Lehigh Valley, PA. So what will you do with your final 20 seconds of spring? We just want to wish you a happy summer. And so once again, streaming live for the moment of the solstice. Only 10 more seconds until summertime. The sun's most direct rays about to strike the earth. And happy summer to all of our viewers. So thanks for tuning into our live stream, our solstice stream. And again, we typically do stream live for astronomical events like solstices and equinoxes. We find all of this stuff to be relevant here at the Smash News Network, Least Busted Name and News. We find it to be relevant, unlike so much content on the platform of YouTube. All right, so let's get back to where we were here. And now moving into our second segment of the day. And this is the segment that usually does appear on YouTube, so let's do it. Here's the sun in 304 angstroms. It's ionized helium from the SDO. And we've had mostly stable sunspots here over the past 24 hours. Likelihood of solar flares is quite high. Likelihood of coronal mass ejections also quite high. Once again, thanks everybody for leaving comments. We will put them on the screen again here momentarily. Next, let's add 171 angstroms to the view. So now we're looking at ionized iron and ionized helium from the SDO. And how about a closer view? What do you say? And by the way, thanks to everybody who voted on our poll last night. And we got 92% of votes wanted us to stream live for the solstice. So here we are, the first moments of summer. We hope you're enjoying yours, and let us know in the comments if you've got any exciting plans for the summer season. Spectacular imagery there from the SDO. Today's featured product is the Galactic Federation Special Forces. I would say to each of you, Universum Liberate, if I could wave my magic wand, I'd set everybody free. That's a quote from Rush. I think Neil Peart wrote the lyrics to that song, Presto, from the 1989 release, I believe it was. Rush Presto, one of my favorite bands of all time. Universum Liberate, the Galactic Federation Special Forces motto. If you're sick of what's going on planet Earth, consider supporting the Galactic Federation Special Forces. All proceeds go to continue this content and to give Smash staff a raise. Now, we typically do stream videos every day live to Twitch. As you can see, we put up 2 space weather videos yesterday, and we streamed for 12 and a half hours, expecting to see more solar flares than we've seen. If you're not seeing all of our videos appearing on your stream, on your subscription feed on YouTube, just head to smashomash.com/smashteam and click post, this link right here. And that should allow you to see all of our videos in one convenient location. Where will you be on the last day of your soul? Will your soul be cast into an ever-deepening and darkening abyss of raining dog poops and bird turds? We hope not. And shout out to our viewers from Munda. By the way, we've released information about how stars really work. It's only for Gold Smash Team members, so if you want to hear about that, we've basically let the cat out of the bag for our Gold Smash Team level members about how stars really work. The hypothesis on the mechanism underlying the solar polar field reversal and solar sunspot cycles. So welcome to Neo Renaissance. We've got the whole basis for the paper, for the most part, already written on the website. Support us that way. You can also become a patron still. Our Patreon still exists. Thanks to everybody who's helped us out. Go visit us on social media. Leave us a comment. Tell us your favorite social media in the comments. And let's continue on. Here's Earth's magnetic moment from space. And again, just in the past hour, we've seen the arrival of some higher density solar wind, looking like the leading edge of a coronal hole high-speed stream. And we can expect several coronal hole high-speed streams over the coming week. We've got some very well-defined coronal holes here, just moving into the Earth-facing zone of the southward, the South Pole Polarity. Anyway, that's the last 4 hours of Earth's magnetic moment from space. Here's the last 4 hours of Earth's magnetic moment from the ground. We show it daily on this daily space weather videos. This data is not viewable in archival form, so you could watch the last 5 years on our channel, showing at least 4 hours of this data per day, courtesy of University of Michigan. Earth's magnetic moment from the ground, geospace delta B. KP index only at 1, despite a high density wave showing up. Not sure how high it's going to go, but this should give us some insight, the real-time solar wind. You see this little density wave here, making it up to about 24 protons per cubic centimeter there. And we also saw a drop in the solar wind speed, so this looks like the onset of a coronal hole high-speed stream once again. And we've just seen the BZ, which is the red line in the top pane there, shift into the negative territory. That could lead to some geomagnetic unrest or geomagnetic storm conditions, so that's something to keep an eye on throughout the day. The field not super strong there at 6 nanotesla. Again, I'm referring to the top pane there, the BT-BZ. BT at 6 nanotesla, BZ now at -4. Make that 5 nanotesla. So not a strong field there, but we may see the KP rise a little bit if that BZ remains negative. Next, go into the magnetic data portion of the video. Here is your GOES magnetometers. Here are your GOES magnetometers, I should say. And some plasma arriving from space. Let's take a look at the polarity of the heliospheric current sheet. Earth lies right in a South Pole current sheet shown here in red. No changes expected to come to that anytime soon. There's the North Pole current sheet moving to the opposite side of the sun there in green. And here's a line of sight field plot. Next we'll move to coronal holes, a super important feature of the solar sunspot and solar polar field reversal cycles. So there's our line of sight plot. You can see the progression of the solar polar field reversal. And here's our coronal hole line of sight plot. You can see those well-defined South Pole coronal holes shown there in red. The sun's B field shown in blue. And if you're wondering what PFSS stands for, it's potential field surface source. Those are magnetic field lines. So here is the last 24 hours in 193 angstroms. And all of these coronal holes here, these are all, as we said, they are South Pole-oriented coronal holes. And we can expect a high-speed solar wind from them in about 4 days. What we're currently seeing is the density shock wave of a high-speed coronal hole wind stream of the North Pole orientation. Let's move to sunspots next. And likelihood of solar flares very, very high as sunspot 3032 approaches the limb. So also sunspot 3038 looking like it might be becoming a little bit less stable here. So don't be surprised to see a flare from that one as well. And we are expecting a coronal mass ejection. We'll get to that in a minute. A couple of minutes. First, some close-ups. Today we've put up 1600 angstroms along with our 1700 angstroms. The 1600 angstroms is ionized carbon. And 1700 angstroms is just extreme ultraviolet light. Great view there. And again, this sunspot here, it's known as sunspot 3038. You can see the leading umbra here sort of accelerating away from the trailing umbra. We may see some plasma filamentary collapses and solar flares associated with that. So here's the zoomed out view to show the full solar disk in those same wavelengths, 1700 and 1600 angstroms. There's a new sunspot rising down here. It's kind of big, but it's not magnetically complex, at least not yet as far as we can tell. So here's the flare profile, and we've moved into a C-class background X-ray output once again. So if you look at a 7-day chart here, you can see we were a little bit below a sea level. Now we're a little bit higher. So despite a downtick in the radio flux here, solar activity not really breaking down. We're continuing to see sunspots, so no spikes in the proton flux. And here's 94 angstroms. This is a great wavelength to view flares. It takes 10 images per minute instead of only 2. Take a minute to soak that in. Good times from the SDO. And let's continue on. So we've brought up a star chart here. Once again, it's exciting times to be viewing the sky in the morning. You've got Saturn, the Moon, Jupiter, Mars, Venus, and Mercury all rising ahead of the Sun. That's what the sky looks like above Lehigh Valley, where we're located. And here's a planetary forecast. As all the planets gather on one side of the solar system, people are scared and spooked because I think people on YouTube are convincing them that the planets are going to kill them. Draw your own conclusions. I'll just say, no. Here's a 1-week forecast. There's where things will be in a week. We'll have a new moon, it looks like, on the 28th of June. Once again, shout out to all my reverse werewolves. What's this? You don't know what reverse werewolves are? Reverse werewolves are people who sleep at nighttime, they are well rested in the daytime, and they're happy, productive members of society who don't eat humans and stay up all night. That's a reverse werewolf. They tend to come out around new moon. So beware of the reverse werewolves. They're very scary and spooky. Once again, thanks for tuning into our Solstice stream. The moment when the sun's rays are the most direct on the northern hemisphere and the least direct on the southern hemisphere as a result of Earth's axial tilt. Take a moment to press like and subscribe if you enjoy the content. Tell your friends and foes about the channel. Once again, thanks for leaving comments, everybody. Shout out to All the Sun. Have a great day yourself. And let's continue on here. Only 5.5 minutes into spring. Let me press refresh. I mean, into summer. 12 minutes into summer, I should say. There you go. And happy summer to all of you folks who've tuned in late. Let's take a look at coronagraphs. Again, we are expecting coronal mass ejections. We'll tell you where next. That's just today's coronagraph imagery. Nothing special happening yet. And how about the view from Stereo A and from the Soho Lasco C3? So I would note this huge prominence over here. We can expect that to either eject or collapse. And I'd say there's about a 99% chance of that partially ejecting at least. So that's something to keep an eye on for the next coming days. It could be headed out into the greater solar system at any moment. Very unlikely to be headed toward Earth. And normally this is about where we would close out our YouTube space weather video, but we're going to continue on, include our bonus features segment and our meteorology video, so stay tuned. We're doing everything in one today, so no BitChute video and no Twitch video, although we will Twitch stream the sun a little bit later. So anyway, this is normally where your YouTube video would cut out. It's with our house favorite 171 angstroms view. And we're going to continue on. So next is our bonus features segment. We're going to start out with the total electron content forecast, the coupled thermosphere, ionosphere, plasmasphere, electrodynamics model, and we're seeing some massive anomalies in the southern hemisphere. Check it out, giving us insight into Earth's magnetic field. It's almost like a little minor Van Allen belt forming down there around Antarctica and the Southern Ocean. You can see this very high level of electron flux right there happening. So a little bit of anomalous electron content occurring there. And the total electron content forecast is showing you the free electrons in the upper plasmasphere, the Van Allen belt, the lower plasmasphere, and the ionosphere. So this whole area in between your GPS satellite and your handset, that's about 12.5 thousand miles of altitude for those GPS satellites. And free electrons can cause huge errors. So turn on your location accuracy services that use Wi-Fi IP addresses to help locate you. So we do see a little bit of a heightened solar wind speed here. It's actually just moved as we're making the video. We don't see any charging hazards at the moment. Satellites are all in clear territory. And once again, thanks everybody for leaving comments. Happy summer to you too, Smash staff. And let's continue on. So here's your GOES electron flux. And I'm expecting this to be a lot lower than NOAA's forecast, because it looks like, once again, another coronal hole high-speed stream is arriving. So let's take a look at the forecast. I'm expecting this to be down here. So we'll see what happens. Again, keep watching the real-time solar wind today. We may not see the end of the density spike yet, as we're expecting a pretty significant coronal hole high-speed stream. But that's NOAA's forecast. Here's the one-year chart of the relativistic electrons. Those are measured by the GOES 16 and 17 right here. From their geosynchronous near equatorial orbit, they're measuring the electrons at the F ionosphere layer using radiography. Speaking of the F ionosphere layer, we'll show that next. That's about 300 kilometers of altitude, and here's the vibrational frequency of that. This data is courtesy of Australian Government Bureau Meteorology. And the ionosphere is looking pretty normal. Nothing to write home about there. We like to show it daily, though, to get people immersed in the data so they have a clue what they're looking at and how the physics relates. Which data sets relate to each other, which data sets don't relate to each other. Here's your anomalygram showing anomaly in megahertz from a 30-day median. It's pretty weird, folks, when you immerse yourself in the data. Often you end up with answers to questions not asked. So this is a normal thing in science, folks. We weren't trying to explain the solar cycles. It just kind of happened through a preponderance of the evidence. Anyway, here's your latest intensitygram. I mean, not intensitygram, ionogram. And there's your latest anomalygram. That's 9:15 Universal Time, coming at you a little earlier today than usual. Next, we'll go to a ground-based solar observatory. This is ELTiday Spain, and check out the huge plasma filaments. Massive plasma filaments here on the earthly side of the sun. Check this one out. Huge absorption feature. More absorption features. These are all plasma filaments. They could all be ejected at any moment. But the most likely place for a CME is on the opposite side of the sun. Keep in mind the likelihood of solar flares certainly rising as this sunspot region approaches the limb. Yeah, solar flares. They happen more often at the limb than on the center of the solar disk. Here's your latest refresh, colorized magnetogram, and intensitygram. So here's this new sunspot rising. Not sure what the number of that will be. To quote Einstein, never memorize something you can look up. Here's your rock back for the magnetic fields. In my opinion, the most likely places to see solar flares would be from here and from here. Once again, happy summer. Here are some more moving pictures. It's the last 2 hours from the GOES 16 SUVI. And you can see a huge prominence here overlapping the extreme northwestern polar region. And how about a composite? Let's bring up the 94, 335, and 193 angstroms. So that's just yesterday and today. And it's time. It's time to kick ass and chew bubblegum. And I'm all out of bubblegum. Wait. It's time to do meteorology and chew bubblegum. And I'm all out of bubblegum. So let's move on to the meteorology segment. Now, we haven't been putting these up on YouTube, except as recorded videos. So we've been putting these on BitChute and on YouTube, and we're going to integrate everything into our space weather solstice stream / meteorology segment today. So here is the scenario for surface winds of the eastern portion of the planet. A strong clockwise rotating low pressure system here in the Southern Ocean to the southwest of Australia. Here are the jet streams. Like sands through the hourglass of time, these are the jet streams of the eastern world. And you folks from under, it is your darkest day. While in the northern hemisphere, it's our brightest day. So happy winter to our viewers from under. Next, the jet streams of the Americas, and check out this bend over the North Atlantic. Yowzers, that is a huge meridional jet stream bend. 180-degree bend there happening in only a couple hundred miles. Highly concentrated jet stream here over central South America as well. Here is the surface wind scenario for this side of the planet. Some strong north to south winds there on the California coast. We've got a large anticyclone here, an upper-level anticyclone happening in the North Atlantic. That is a high-pressure zone, likely accompanied by clear skies. Here are the surface winds of the European and African zone. Let me put your chats back on the screen here for a minute. Thanks, everybody, for leaving us comments. And here are the jet streams of Europe and Africa. Another anticyclone here over the Western Sahara. That is another high-pressure zone. Anticyclones rotate clockwise in the northern hemisphere. Jupiter's Great Red Spot is an anticyclone. A lot of people think it's a storm. It's really a high-pressure zone. And while it is accompanied by high winds, it isn't a storm in the context of what we would call a storm on Earth. It is a high-pressure zone. Storms on Earth are low-pressure zones. Let's continue on. Frost advisories happening in northern Maine, and some flood warnings there over most of New Mexico, it looks like. Flash flood watches, yowzers. And some excessive heat there in the north-central portion of the Great Lakes region. If your county's lit, head to weather.gov, click your county. Here's your real-time lightning map. This isn't a real-time lightning map. This is the NASA GOES Lightning Mapper. Real-time lightning map is next, but that's the last about 10 hours, and quite a lot of lightning here in Mexico and Central America. Look at the amount of lightning. It's berserk. Check it out. Yowzers. That is an intense amount of lightning there. And here's your real-time lightning map from lightningmaps.org. Lightningmaps.org, powered by blitzachtung.org. German, the best language to curse at people in. Du bist ein Schweinhund. Du bist ein Wasserkopf und Dummkopf. Ich möchte ein Franziskaner, ja. Das ist ein prima Weißbier. All right, continuing on. Let's see if we've got terrestrial lightning in the U.S. It looks like indeed we do. Hey, Rochester, Minnesota. There's a powerful cell there to your northeast. Anyway, we'll zoom back out. There's your real-time lightning map. Continued sporadic lightning there over large portions of the planet. Next, we'll look at the water vapor environment over the Pacific Ocean, Earth's largest body of water and largest surface heat sink. Water, it has a very high heat latency, meaning it takes a lot of energy to heat it up. Once again, heavy rains happening in Mexico. You can see that water vapor vanishing from the map. That's a result of rainfall. Next, looking at your temperature anomaly to kick off summer here to show the 2-meter temperature anomaly based on the GFS model. That's degrees Celsius. That's where you'll have anomalous temperatures over the next 72 hours. And here is your pressure and precipitation forecast based on that same GFS model for the same period, the next 72 hours. These tend to be accurate. A little bit of snow expected to fall here in Wyoming and Montana to kick off summer with some snow. Continuing on. And here is our satellite imagery from windy.com, and you can see how far these fully lighted regions of the planet go. That's what you call summertime. It's the brightest day of the year for the Northern Hemisphere and the darkest day of the year. It's the darkest day of the year for the Southern Hemisphere. Yesterday was your last day of spring or of autumn. All right, let's continue on here. Windy.com, they got a great mobile app. Check that out if you like. Windy.com, perhaps appearing on our cycling jerseys in the near future. We'll reach out and see if they'd like to sponsor the team. So here is our U.S. Doppler radar view, the full 50 state view. We'll fixate on the lower 48 as we do on our meteorology segments. You can see some precipitation here making its way south across New York, headed toward Pennsylvania. Here's a shortwave radiation map showing clouds and fog. It's too dark over most of the country to use the visible satellite, so we use the 3.9 nanometer radiation map. And here is water vapor. We've got this north to south flow continuing. It's a cold morning once again in Pennsylvania. That's where we will close out our Solstice stream. Let's put your comments back on the screen one more time. Thanks everybody who's left comments and actually realized that the video existed. YouTube assures us that their thumb is not on the scale, so let us know in the comments if you believe them. Here is our recap, the U.S. Doppler radar map. Here is the shortwave radiation showing clouds and fog as we get more air from New York infused into Pennsylvania. And last but not least, the water vapor map that should help out everybody who's looking at a Doppler and going, how is this system going to move? We've got moisture being sandwiched in between some dry massive air. This is a high pressure. This is a high pressure. And in between that moist air is an equivalent low pressure. That's where we'll close things out. Once again, happy summer. Thanks for tuning into the Smash News Network, least busted name in news. And may that solar wind be at your back. Opinions expressed in this live stream, not necessarily the opinions of Smash News Network, least busted name in news.